Which one? First one? As in everything? Can. Okay, so 5.4a is instead of expressions, 5.3 is expressions, 5.4 is now equation. So all these are actually expression. This phrase is equals to this phrase, 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 and phrase. They are all phrases. Okay? 5.4 is equation. This one is equal to something, then we can throw the log away and so on. The idea on how do we solve for equations is that we try to combine everything together, remove the log together, and then make sure the bases are the same, remove the log together, and then we can solve it like our regular equations. Okay? So I will start off with number 1. Okay, number 1a, this is LG half x is equals to 1. Correct? LG of half x equals to 1 or log of half x equals to 1. Now, this log, what base is this? Base 10, okay? So this is in base 10, okay? If you are not confident, you can write log base 10. Sorry? 1 TV equals to? Oh wow. Okay. Alright, so the unknown is inside the logarithm. So as usual, when you want to solve for equation, it's like going home, you take out your shoe or you take out your socks first. Take out your shoe first, right? The outer one first. So the outer one is your log base 10. So you remove the log base 10 by converting to index form. 10 to the power of 1. So x is equals to 20, like that. Okay? Can? Correct? Wrong? Correct, right? Correct, right? So you don't need to log both sides. Just take away. Okay. Next one. Okay. Next one for B. Okay, so this is this one, ln x squared is equals to 2. Okay, so this one I want to caution something. Okay, I want to caution something. There's a difference between this and there's a difference with this. So what's the difference? Which one you can apply the law of logarithm to bring the 2 in front? The first one or the second one? The first one, so this one is ln of x squared. Okay? Ln of x squared. So when the square is inside the logarithm, you can put the square outside. Okay? This one over here, this is ln x whole thing squared. So it's a bit different. Okay? You do the ln first and then you square the number. Okay? So it's a bit different. So same thing when we solve, same issue. Which one is the outermost shoe to take off? So this is the shoe, you take off the shoe. So how to take off the shoe? Square root, okay? So this one, ln x will be equals to square root of 2. Ln is base e, correct? So x will be equals to base e to the power of root 2. We can leave it like this, no need 3 as f. Okay? Can So we remove the one outermost first. Which one is the shoe, which one is the sock, which one is the pants? Okay? Can So this is B. Index form. Okay, example okay, 10 to the power what is 1000? 10 to the power of 3 is 1. Agree? Correct? Agree? So this is the base, this is the power, this is the random number that we have, correct? So base and power together, right? So this one is equals to this. So generally, right, what I see, if you want to be like physically moving, the 10 will come here, the 3 will go up. Again, sorry? AX equals to Y. Where? Okay, so log base A of Y is equals to X, correct? Right? So if you want to remove the logarithm, the A will be the base, the X is the power, correct? So y is equals to a base a to the power of x. Okay? Okay. Something like this. Okay, so next one, part C, ln x log 3. Okay, C we need a bit of calculator. Okay, ln x log 3. So the problem is you have logarithms on both sides, different base. Then stuck how to solve, correct? Actually, not to worry. This is just a number. Already a number. You can use your calculator to get this number. It's like pi, like square root of 2. Correct? You only need to solve for x. And this base e is the annoying one, correct? So we just need to remove the shu. The shu is your base e. So x is equals to e to the power of log 3. So if you want, you can use your calculator to get the answer in 3SF. So what's the answer in 3SF? How? Suddenly very easy, right? Is it suddenly very easy or still not sure? Very deceivingly easy. O level harder? Oh yeah, actually O level. 1.61. So this is 1.61 to 3 significant figures. Okay, so not to worry too much. Okay, just need to remember where is the unknown, which one are your numbers. Okay, next one, find the value of each of the following equations. So the next type of question is we need to do a bit of solving. Now the x is in the index. Okay, now the x is in the power. So what do we need to do is we need to get rid of the shu. So for this one, x is all the way inside. Where is the shu? The shu is my number 3. Okay, how to remove number 3? Divide by 3. So e to the power 2x is equals to 8 over 3. Next, what is the SOC? The SOC is your base e, correct? So base e, how to remove the base e? Logarithm ln. So this is 2x. Now it's log base e of 8 over 3. So this one will come to the base over here. Okay? Then what is the next thing to remove? The 2. So I divide by 2. And there you go. This is the final answer. This one or 3SF also can. You can leave it like this. Now we are going to continue with the 5.4a. Okay, but the other kind of logarithm. So we'll continue the worksheet until we are bored with this worksheet. Okay? Can? Can, okay. Come. So let's. Okay, so this is just for laughs. Okay? Can? Satisfied? Okay. Okay, so part 2. Part B. Okay, so to part B. Can? Can? I'm doing now, so yeah. Okay? Can, Okay, I start. Okay, so first, so this is another kind of equation that we may need to solve. Now, here, the reason why we have log is so that we can settle equations like this. Okay, so the thing over here, x is in the index, is blocked by the base. The base 7 is a problem, so we need to remove the base 7. Okay, so how to remove base 7? So we just put it on the other side, base 7. Okay, so what is log 27? Log 27, you can change your base to LG2, LG7, or ln 2, ln 7. Then you can, evaluate from there. Okay. So this is 0.356 to 3SF. Okay. Okay, the next one, C. C, you have a 4 times of 2, 3x minus 2, 5. Okay, so how do we solve this kind of thing? Same thing. You can combine them because same base, you can combine them. If you are lazy to combine them, you can throw them away. How to throw them away? So this will be 3x minus 2. When you divide by 4, this is 1.25 or 5 over 4, correct? 1.25 or 5 over 4. Right? Then the x is in the index. We need to remove the base. How to remove the base? Use logarithm. So we have 3x minus 2 as a power. So this 5 over 4, the base is 2. So we put 2 at the base, like this. Put 2 below over here. Okay? Something like that. You can see this action over here. Then we will just need to do x is equals to 1/3 over 2 plus log. Okay. Okay, if you want a specific number, then you can do some calculation over here. Right? 2 plus ln 5 over 4. Whoa. Over ln 2. Then you can key in your calculator. Okay? So this one will give you okay, 0.774 3SF. Okay? Can? So it's just a matter of, let's say if you have something like this, just change the base. Change the base to ln. Okay, when you key in your calculator, can change the base to ln. Okay? Can, So it's a bit congested down there. Okay, so I think there's nothing much to talk about until okay, E. Let's look at part E. Okay, let's look at part E. Part E, even though this is an index, but we'll need the help of logarithm. But how are we going to do so? Okay, if you notice, right, because we are solving for x, so it is convenient to collect all the x together and to form them into one x, that's all. So actually, we can make use of the law of indices. We will just need to arrange this nicely. So we have 2 power x over here. 3 to the power of 3x is technically 27 to the power of x. Agree? 3 to the power of 3, then the x is outside of the bracket. Okay, I can also divide by a 7 power x over here. This is equals to 5. And I can combine all of these together as 1 because the powers are the same. So I have a 2 times 27, 54 over 7 to the power of x is equals to 5. So this is really milking all the laws of indices. Okay, because of the same power, I can combine everything into a fraction. Then this is the annoying base, so I will just remove it. Or if you are impatient, you can put the log in front. You can follow this working. Or you can follow this is equals to LG of 5, x in front. So then you just divide log 5 over log of 54 over 7. Okay, so this one will give you a beautiful and a number. Uh, 0.788, okay, to 3SF. Okay, like that. So you can do this. You can also do this. I think I skipped one step. If you can see, you can also do something like this. Okay, then you'll be base 54 over 7. Also can. It's just that very ugly to type. That's why you don't see people doing it. But technically it's the same. You can do it. Okay, can Okay, anyone need help with question F? The 4? The step? Yeah, so the 2 I add to the other side, divide by 3. This one plus 2, divide by 3. Don't need this base 2 what? If I log 2, log 5 over 4, right, it's just LG2 divide. So it's this one, same, LG or LN. Can one. You just need to do what you're used to. Okay, just don't do roundabout stuff. Okay, so I think we are all okay until we are at question 3. Anyone still need 2? The last one, or 2? Oh yes. 2F, huh? Okay. Because this is, because I skip a step. This one, power law, the X in front. Okay, like this, then I divide. Okay, now alternatively, right, if you want to do this, right, you can also write X is equals to log base 54 over 7, 5, also can. Then you change base to this, also can. Okay, can, no problem. Okay, let's look at 2F. Question 2, part F. 2 to the power of 2x plus 1 is equals to 4 times 3 to the power of x minus 2. Okay, same problem as E. Okay, you have x on both sides and it will be good to collect all the x's together. Okay, so how do we do this? Let us split this up. Okay, before we split up also, you want to solve by law of indices also can. You want to solve by law of logarithm also can, up to you. So what you want to do is, you notice the 4, same base as 2. So I will just put this over here. 4 is actually 2 square. So I'll just write this as 2 square first, just to get ready. Okay, I divide by 4 first. And the next thing is, do laws of indices over here. 2x minus 1. Okay, my power minus 2. So this, I get something like this. Okay, so there's 2 ways to go from here. Let me show you the logarithm way first. So method 1, the logarithm way is to do log on both sides. So I have an LG 2 to the power of 2x minus 1 is equals to LG of 3 log 3 of x minus power x minus 2. Get the power in front, so 2x minus 1 times log 2, then x minus 2 times log 3. Okay, log 3, ln 3 also can, up to you. Okay, then the thing is, because if you were to gather all the x as a fraction, you have a fraction with x on top and below, a bit hard to solve. If you can foresee, if this one divide over here, log 2 divide over here, you get 2 fraction, right? Correct? But the fraction numerator and the denominator both have x's and a bit hard to solve. So what you can do is expand. So you have your 2x log 2 minus log 2 is equals to x log 3 minus 2 log 3. Okay? Then I will gather all my x's together. Gather all my x's together on the left. So 2x log 2 minus x log 3 is equals to log 2 minus 2 log 3. Looks a bit confusing now because there's a lot of steps going on. And later I'll show you the easier method. Okay? So this one over here, I want to solve for x. Correct? So what I need to do for the x is, I need to collect them together. How do I collect them together? Factorize the x out. So x times of 2 log 2 minus log 3 equals to log 2 minus 2 log 3. Does anyone get OCD like me switching between cursive L and non-cursive L? No, no OCD. Okay, can. Okay, so what is x? X is log 2 minus 2 log 3 over this ungodly thing. So this is another number that we can divide. Okay, then you just punch into your calculator and see what is this. Okay, so this will give me negative 3.8 2 to 3 SF. So this is method 1. Okay, using the logarithm way. Now, method 2, if you want to use the law of indices, it will make things a little bit easier. If you want to use law of indices, we break up and collect the x right away. So this one we have from 2 to the power of 2x minus 1. I can write this as 2 to the power of 2x times 2 to the power of negative 1. Agree? The other one will be 3 to the power of x times 3 to the power of negative 2. Okay, let me rewrite this nicely so that it is just x. So this is 4 to the power of x, right? 2 square bracket, then the x outside of the bracket. 2 power negative 1 is just divided by 2. Then I have a 3x over 9, right? Negative 2, so divide by 9. Then I can do some I can collect all my x's over here. It's just a swapping of place. Can see? Can see? Then right, what's going on over here? 4 over 3. Why my answer different? Oh, okay, a bit different. Okay, so now I can collect my x as 1 power, and I can do ln both sides, or I can do the what I've done previously also can. Okay? Okay, so after this is the annoying base. So let's get rid of the base and bring the power down. So I will have a log base 4 over 3 of 2 over 9, like this. Okay? Then how to change the base? You can change to log 10, or you can change to natural log n. So this round I just change to ln 2 over 9, then ln 4 over 3. You still get your same answer. Okay? So ln 2 over 9, then ln 4 over 3. You still get a bit weird, huh? Did I do any calculation error somewhere? I think my error is there, right? Ayah, you see lah, you see. Wait, correct what? Okay, I'll try to fix this, but yeah. Okay, somewhere over here. Okay, I'll fix this and I'll put a correction notice. Okay, so by right, 2 methods should give you the same answer. Where error? Where got error? Where? Okay, somewhere got error. It's either that or I copy wrong question. Okay, I'll fix this at home. Okay, we just live with this uncertainty first, okay? Can Okay, so this is 2F. Okay, let's look at question 3, part B. Any questions so far? I made a mistake somewhere, but I don't know where. So I'll go and find out soon. Okay, question 3, log base x. Wow, log base x of x plus 4 is equals to 2. Okay, so this one, even though it's a logarithm, are very easy. How? This is the base, so we remove the base, correct? Take the base and put on the other side. So we have an x plus 4 is equals to base x power 2. Quadratic equation. Okay, so now it becomes x squared minus x minus 4 is equals to 0. So we need to do this. So negative b plus minus b squared minus 4ac, because I cannot factorize, over 2a. Okay, so mode 5(2). Okay, so I have a 2.56 or negative 1.56. Do we reject any of this answer? I typed calculator wrongly? Which one? Oh, okay. So it's a calculator problem. Okay, can. Okay, but for this one, which one do we reject? Do we reject anything? Do we reject a positive number? Reject the negative because the base is x and the base must be a positive number and cannot be 1. Okay, so this one we reject. Okay, like that. So remember to double check and reject based on the original question. Okay, my calculator problem. Okay, can. Let's try. So ln 2/9 divided by ln 4/3. My first one calculator wrong. Log 2 minus 2 log 3 divided by 2 log 2 minus log 3. Okay, can. Okay. Okay, now the word is balanced again. Okay, can. Okay, can. Number, that's 3b. Yeah. Where? Okay. I messed up big time. 3x. I think it's the afternoon. I have to blame the afternoon. Okay, can. So let me just scoot this away. I was so confident. Okay, can. So x 4 and 1, so minus 4 plus 1. So x equals to -1 or x is equals to 4. We reject negative number. Okay, reject. Okay, like that. Can? Yeah, usually I don't give weird questions like this, but yeah, weird things may happen. Okay, can. Okay, I will only do one of the next question and then we'll call it a day, unless you have something serious that you want to go through. Let's go through. Okay, 4a. I think 4a will be our last question over here. Okay, 4a. Okay, 4a, I have a log base 3 of 2x plus log base 3 of x minus 2 is equals to log base 3 of 6. So now, over here, we have logs on both sides and the logs are all separated. We need to combine all the logs together and remove the log together, unlike what we've seen previously. So here, same base, we can combine them together. So same base, and then combine the content, and then this is log 3, base 3 of 6. Then, very nice, the base are the same. Because the base are the same, we can remove the base together. So this is 2x, x minus 2 equals to 6. Or, another reason is because the base are the same, the content must be the same. So we are just comparing the content. Okay, so let's expand like this. Let's divide by 2 like this, and let's factorize because this looks easy to factorize. Then x is equals to -1 or x is equals to 3. Do we reject anything? Reject the negative number. Do we need to reject negative number? Yes, because of this one. Okay, reject this. So, okay. So we reject this one. Okay? Can. Okay, so it looks okay, right? Not so bad, huh? Is it okay? Do you feel okay? You don't feel okay? Never felt okay. Any other questions to worry about? The last question don't need, the last question very easy one actually. Yeah. Oh, there is a 5.4b. Okay. Okay, can? Any other questions to go through? Don't have? Okay, let's go with 5.4b. Okay, I think I can go through one or two questions from there. And that's all for logarithm actually. Then it will be applications already. By the way, you all got watched the video for binomial. If you haven't watched, I think this weekend will be good to watch. Okay, 5.4b. Question 1a. Anyone need help with question 1a? Question 1b. Okay, I think I'll do A and B. Any? Okay, the rest I'll let you try. Okay, so 1a and 1b. Okay, so 1a. Okay, so 1a looks like this. So I have a log base 2 of x plus 2 equals to 3 log base x of 2. Okay? So far so good? Can Okay, so how do we solve for this? Okay, this requires another kind of skill. So if you try all the other methods of solving and then you cannot solve, you may need to consider that this is actually a quadratic equation. So how does it look like? Actually, it looks like this. So I have a log 2x over here plus 2. Now, this is base 2, this is base x. So it will be convenient if we change everything to base 2. So let's try to change this to base 2. So if you remember your special results for changing your base, if you want to swap the base and the content, right, it is just simply 1 over the swap content. You see it? Remember this special result? If you cannot remember, then you just change to base 2. So log 2, which is 1, log 2x at the bottom. Okay? Now, this one is numerator, this one denominator, correct? So means I need to start to substitute already. So substitute u to be equals to log base 2 of x. So u plus 2 is equals to 3 over u. Quadratic equation you can see. So u square plus 2u is equals to 3. U square plus 2u minus 3 equals to 0. So u minus u plus 3, u minus 1 is equals to 0. So u equals to negative 3 or u is equals to 1. Then we need to come back to this. So log base 2 of x is equals to negative 3. Log base 2 of x is equals to 1. Cancel. So x is equals to base 2. So base 2 power negative 3. So this is 1 over 8. This one base 2 power 1. So answer is 2. Both are valid answers. Okay, both answers accepted. Okay? Can Now seems okay All's well, ends well. Okay? Okay, last question of the day. Then I won't touch this already. Okay, for part B, we have a log base 2 of x squared is equals to log base 2 of x whole thing cube. Okay, so we need to do a little bit of surgery. Now, this is the whole thing cube. This one, right, is only x squared. And you see that actually I can have a common term over here that I can use to substitute. So let me push the 2 out. Let me bring the 2 down. Okay, then I substitute. Okay, so let me substitute u to be equals to log base 2 of x. So I have a 2u is equals to u cube. Okay, then rearrange. So u cube minus 2u is equals to 0. So this is a cubic equation. How do we solve cubic equation? Many methods. Let's try to use the straightforward one first. I have a u square minus 2 over here, factorize. Okay, then u equals to 0 or u square minus 2 equals to 0. Then u square is equals to 2. U is equals to plus minus square root of 2. Okay? So it means now we have 3 answers to consider because it's a cube, right? 3 answers to consider. So the first one, u equals to 0. So we have our log base 2 of x is equals to 0, or log base 2 of x is equals to root 2, or log base 2 of x is equal to negative root 2. Okay, sorry, a bit more, then I'll let you off for your next break. Okay, so here, let's solve for x, remove the base 2. So x is equals to base 2 power 0. So x is equals to 1. Oh yes, sorry. No, which is not here. Sorry. Okay. Next one, base 2. So 2 to the power of root 2. Okay, the answer is just here. Next one, remove the base 2, power of negative root 2. Then you can leave the answer like this. If you want one more step, here in 3SF. If you want one more step, this one in 3SF also can. Okay? So mainly like this. Okay, so now when you are in the cubic equation, you need to have 3 roots. Power 3, 3 roots. Okay? So mainly like that. So I think this is all for logarithm. I think you've seen in the past 1 hour or so, right? The logarithm is, you need to be familiar with the laws to do the basic things. Sometimes you need to combine them and remove the log at both sides together. Sometimes you need to separate the logs and to substitute at each logarithm. Okay, so these are the different skills that you need for logarithm. Okay.